This is my favorite time of night, the time I get to spend with all of you. We're going to start by taking 1/4 plus 5/11ths, and we're going to add them. Now, person A may say that if I add 1/4 and 5/11, I would get 6/15. Person A would be wrong. Person B might say that if I take 1/4 plus 5/11ths, I'd have to change them to have a common denominator. Okay, that's right. What do we change 1/4 to? Well, if I look between 4 and 11, I actually got to look to see what the common denominator is, and I would say that that's probably going to be 44. So then 1/4 gets changed. Let's see, 44 to 4. We have to change that to 44. So 4 times 11 is 44. 11/44. Read this off to the side, and the 11. Okay, that also has to be in 44ths. So it's times 4. We get 20. And then we keep here. Let's move that over down here. Then we add the numerator, and I get 31/44. That is correct. Let's get rid of this for a minute, and let's go to person C. If I get 1/4 plus 5/11ths, rather than write the 44 multiple times, I might just say, well, my LCD is 44, so I know it's going to be all over 44. And then I would say, well, 11 times 4 is, 11 times 4 is 44, so I have to multiply the 4 by 11, or sorry, this by 11, and this by 4 to get there. Once again, you still get 31/44, but you've done it a little bit quicker. Let me show you that one more time in another way. Let's take 8/7 plus 12/15. 7 and 15 really aren't going to have anything in common, so my LCD is going to have to be 7 times 15, or 105. So when I add these together, I know that I'm going to add them in such a way that they're all going to be over 105. So since I have to multiply 7 by 15 to get 105, I have 8 times 15 plus then 12 times 7 all over the 105. And then I would get a final answer. 8 times 15 is 120. 12 times 7 is 84 for 105. And I'd add to get 204/105. Something that may not be obvious all the time is that when we add fractions, we might be able to simplify. 204 and 105 are both divisible by 3, so if I divide by 3, I would get 68 over, that'd be 35. And we have a final answer. Okay. Now, if you're seeing this, I want you to write your favorite color. Mine is blue. And then I'm going to erase it, so that people who haven't done the notes can't see that. Okay, continuing on. The rule with fraction adding is that if I have a over c plus b over c, that's equal to a plus b all over c. Similarly, if I have a over c minus b over c, that's just equal to a minus b all over c. And it's this form that we're going to be focusing on with the rest of this lesson. Okay, let's do some examples. Number 1. 6t minus 8, or minus 1 over 8, minus 5t minus 4 over 8. I can state an LCD of 8, but it's already in terms of an LCD of 8. So what I'm really going to do is just take my numerator, 6t minus 1, and I'm going to subtract this using the distributive property. Minus 5t plus 4 all over 8. That plus is essential because that's from distributing the negative. And then we have, let's see, the 16 and the 5, negative 5t give us t, the negative 1 and the positive 4 give us plus 3, and all over 8. Continuing on, number 2, I'm going to do 4y minus 2 over y minus 5 plus, and let's do 3y plus 1 Well, same thing, I can just add the numerators. So I'm going to have 4y minus 2 plus 3y plus 1 all over my LCD of y minus 5. And I get 7y minus 1 over y minus 5. You may have noticed that we're not saying anything about restrictions here. That's because if I go back up, I can do a little inserting and put directions in, which is going to be simplify and assume no denominator equals 0. Let's go back down. Number 3. Let's try m over 3 minus 6m plus 3 over 12. Okay, now we've got our first one with an LCD, except before you state an LCD, let's simplify our fractions. I can actually look at this and pull out a 3. So I get m over 3 minus 3 times 2m plus 1 over 12, and simplify this 3 and the 12 to become a 1 and a 4. Now don't simplify across minus signs, that would be dumb. Well, not dumb, but just pointless. And so I get an m over 3 minus a 2m plus 1 over 4. Now my fraction's a little bit simpler, but you're about to see what's going to happen here. Really, we're going to have to scale it back up to be an LCD of 12. So if I say we have an LCD of 12, that means I'm going to put the next step, I'm actually just going to write the whole thing over 12 and take the first one times a 4 over 4, which still gives me the 12 in the denominator, but I end up with 4 times m minus, and then the 4 I'd have to multiply by a 3 to get to 2m plus 1, so 3 times 2m plus 1, and then just simplify. That'd be 4m minus 6m minus 3, all over 12, or negative 2m minus 3 all over 12. Let's continue on to number 4. I'm going to draw a box. I'm going to put n over 3 and n plus 1 over 4. And what I want you to do is find the perimeter. We know that a square has 2 lengths and 2 widths, so I'm going to say 2 times n over 3 plus, this is n plus 1 over 4, so plus 2 times n plus 1 over 4. So this first one becomes 2n over 3. The second one, the 2 and the 4 can cancel, and I would get n plus 1 over 2. Then I want to state an LCD of 6. I'm going to multiply this first one by a 2 over 2, and I get 4n plus, and multiply the second one by a 3 over 3, and I get 3 times n plus 1 all over my LCD of 6. So then I have 4n plus 3n plus 3 over 6, or 7n plus 3 over 6. Okay, next example. Got several left. Number 5, 5 over 6y minus 7 over 12y cubed. Okay, now we're starting to get a little bit more complicated. We're going to state an LCD. If I compare the 6 and the 12, I'd have to state a 12, the y and the y cubed. I want a y cubed. Let's figure out what do I have to multiply the 6y by to get to 12y cubed. It'd have to be a 2y squared. So I get 5 times 2y squared minus 7. Really, I don't have to multiply by anything, so I'm just going to leave the 7. I'm going to put it all over the LCD of 12y cubed. And we have 10y squared minus 7 over 12y cubed. That one's done. Finally, number 6, our last one. We have n over n plus 3 plus n plus 9 over n squared plus 8n plus 15. If you see anything that you can factor, factor it. So I'm going to say the first one is n over n plus 3 plus n plus 9 over, I'm going to factor this, n plus 5 n plus 3. Now I can state an LCD of n plus 5 times n plus 3. Well, the question now is, what do I have to multiply by? For the first one, I have to multiply by the missing n plus 5 over n plus 5. So my numerator is going to become n times n plus 5. Now the second one I don't have to multiply by anything, so that's just going to be n plus 9 over my LCD of n plus 5 times n plus 3. Now we have to simplify the numerator before we can cancel anything. I have to multiply it all out. N to the second plus 5n plus 6n, plus n plus 9 all over the LCD of n plus 5 times n plus 3. Keeping that factored so that I can see if I can cancel anything later. Then I have n squared plus 6n plus 9 over n plus 5 times n plus 3. Well, that numerator can factor. That factors into n plus 3 times n plus 3, or n plus 3 squared over n plus 5 times n plus 3. So one of my n plus 3's is going to go, and my final is n plus 3 over n plus 5. Believe it or not, we are done.